Assalamualaikum warahmatullahi wabarakatuh and good morning everyone. We, Noor Helmi Wirafi'i, Erin Abhishegam Peter, Shaman Sandramurti and Livendra Dev from class DKM2B have prepared a report based on the presentation we have done to show and convey the facts we have provided in our video. To begin, we were given the topic differentiation. Differentiation is a part of mathematics which branch out from calculus and algebra. Differentiation is often used to calculate the minimum or maximum quantity of the product. We can also use differentiation to determine if a function is increasing or decreasing with the value of the second derivative. The second derivative means we have to differentiate the expression or function twice. If the final expression, function or value is in positive value, then we should have a minimum point, and if it has a negative value, then we would have a maximum point. Besides, we can also use differentiation to calculate the rate of change of a certain value or the area and the volume of certain shapes. Differentiation has its many uses in a huge variety of fields such as engineering, architecture, music theory and production, manufacturing industry, and carpentry. And we are going to present about the uses of differentiation in engineering.
Good evening to Puan Hazina and all my beloved classmates. My name is Aaron Abhishek Peter from class DKM2B with matrix number 09 DKM21F 1006. Today I'll be presenting about applications of differentiation in engineering, which is supposed to be in real life, and I'll explain further into it of the applications. And before any example that will be given by my group members. So let's get right into it. So following the slide, there's three main points that I've given. So the first is rate of change of area or volume of certain object, and second is the maximum and minimum of some quantities such as cost of object, strength of the object, profit or loss gained from the project, which usually in the site, or you go for of profit of you selling or buying any object for any project. So the third is to find the velocity of acceleration of the moving object that has been built or that is going to be built. Okay, so I'll explain in more detail. So engineering, first of all, we have to understand that engineering is a branch of science and technology concerned with the design, building and the use of engines, machines and structures. Since it is a branch of science, this field is very dependent on mathematics and calculations. That is why when we study, if you are taking an engineering course, there's a lot of calculations which involves maths. Even though if you study engineering science, there is still maths inside it. So that's why. So there are over hundreds of mathematical formulas and laws used in this field, and one of the laws that plays a big part in this is differentiation. So as mentioned before, differentiation has its many applications and its applications on engineering, which has its ability to find the area or volume of a certain object to determine the maximum or minimum values of particular functions. And if combined with integration, which is the next topic, we can find the velocity or acceleration of moving objects. So in detail, and the most common usage of differentiation in engineering would be to find the minimum and the maximum values of a particular object or quantity, which usually will use the graphs to find the maximum or minimum value of an object. So for example, you can figure out the maximum or minimum cost of the total product used, the pay or salary for the workers, the loss or the profit that can be gained from the project, or the strength of the object. Besides, in engineering, there are some times where the engineers has to design and build a moving object. To find the maximum and minimum velocity or the acceleration of the moving object, we can use object. Okay, so we can use differentiation to derive the expressions and to find the values of these quantities without the need to use its respective formulas. So basically, what I just said was usually we can see this happening in civil engineering, where when they are building they're starting to start a project for building. They have a lot of costs to check. They have a lot of objects, a lot of materials to buy and see if it's worth it. So in that sense, by using differentiation, they can see the best way to spend and see what's the profit they can get from projects, and check if the project is going on the right way. Check the strength of the project and the object, which is the building. And yeah, so that's about it. Thank you.
Hello everyone, my name is Div and I'm from class DKM2B with a matrix number of 09 DKM21F1106, and today I would like to solve and show you how to solve a question that an engineer would solve to create a prototype of an object. So this is how I would like to solve my chain rule questions, because this one is a chain rule question. So first I would like to write what they want and what they give. They gave us they wanted us to find that the rate of change of volume right before the balloon explodes, which is at radius 12 cm, and they also gave us the rate of change of the surface area of the sphere. So to find dv dt we need a chain rule. So the first chain rule I'm going to write is dv dt equals to dv dr times dr dt. Okay, we need to find dv dt. We can find dv dr and we can find dr dt, but none of it is given. So for dv dr, first we need to differentiate the volume of a sphere's formula. We have to differentiate this formula. So 4/3 pi r cube. Differentiate this dv dr, we should get 4 pi r square. Okay, and dr dt, we don't have any formulas to differentiate rate and time, radius and time, so we have to use a chain rule. So a chain rule that I can think is dA dt times with dA dt is equals to dA dr times dr dt. Okay, so for this also we need to find one more thing, which is dA dr. So for dA dr, we have to differentiate the area of the surface area of a sphere formula, which would be A is equals to 4 pi r squared. So if we differentiate this, we should get 8 pi r. So take this and sub this inside, and we already have 20 pi, so we can sub inside. 20 pi is equals to 8 pi r times dr dt. So we just have to do algebra and we can find dr dt, which would be 20 pi over 8 pi r. If we simplify this, we should get 5/2 r. Next, since we have dr dt, we can just sub inside this main chain rule, which would be dv dt times with
Now we have seen for the questions. Now, in conclusion, we can say that mathematics plays a very important role in our daily life routine, because engineers have used differentiation, a branch of mathematics, to build, create our home. It was also used to design our house plans as well. Hence, we would like to wish to all of you that you should understand and learn this subtopic, because it plays a big part in the course we are studying, and if you hope to continue this course in your future, you will see it quite often. Remember, the basic logic of a building is, if only the base of the building is strong, only then it will last long without being demolished. So Please make sure your base in differentiation is strong before you proceed to a higher level of studies. Thank you.